Nuclear fusion, the power of the sun. So fusion and fission are similar words, but they're different. Fission is splitting a large nucleus into smaller ones, and fusion is combining two lighter nuclei to form a heavier one. They are both highly exothermic because the daughter nuclides that are formed have greater binding energy per nucleon. So fusion is the energy source of the stars, not the movie stars, but the actual stars. As we hear all of this, dancing with the stars. No, these are the real stars. And it's the basis of the hydrogen bomb. So the atomic bomb used fission. The hydrogen bomb uses fusion. And it's actually a lot more powerful. It has up to 1,000 times the explosive force of an atomic bomb. I mean, atomic bombs are huge, and a hydrogen bomb is 1,000 times more explosive. So what happens here in this fusion reaction is you have a hydrogen 2 atom and a hydrogen 3 atom combine, and they form a helium 4 and a neutron. So these isotopes of hydrogen have their own names. Deuterium is hydrogen 2, tritium is hydrogen 3, and hydrogen 1 is protium. So we've got tritium and deuterium coming together. In the process of mixing it up here, we get a helium 4 and a neutron, and a heck of a lot of energy. So what the hydrogen bomb does is it takes a small fission bomb, because you need some energy to get this thing started. The fission bomb provides the energy to get the hydrogen bomb fusion reaction started. Nuclear fusion would be a great power source, and it has been highly investigated. The energy density here is 10 times higher than in fission, and the products that are formed have fewer problems than we get from nuclear reactors. The problem is this happens at such a high temperature that it vaporizes any material that it's in contact with. So there's no metal, there's no substance that you can contain this reaction in. So then how do you even do this? This is a Tokomak fusion reactor. And here, instead of trying to use a physical material to contain the reaction, it uses magnetic fields to contain the reaction. So it's kind of science fiction-like, right? Because you see people put in a force field and they can't escape the force field. You can't see it, which makes making the movie a lot easier. But those sorts of things actually do exist. So in order for fusion to occur, high temperature, that produces a plasma, which is a fourth state of matter that we don't usually talk about in general chemistry. That is a state of matter in which some of the atoms are actually ionized. So when the fusion occurs, you have a plasma, very high temperature. Come on, Sari.